Felix, let's quiet down. Let's go. Here we go. Exercise 4B and C, truncus and square roots. Quiet down. Now, what I've taught so far is how to do or how to sketch and how to read rectangular hyperbolas. Today you're going to use exactly the same skills and you're going to learn how to sketch truncus and square roots. I'm going to show you exactly the same ways that I've done in the last exercise, and you'll find that it will be the same drill over and over. That's why I want you to copy it down. It's the same techniques. If you could read the last one, you could read this one. It's the same things. Okay? Ben. Thank you. Here we go. Truncus. This is what a truncus function looks like. Copy this down. Y equals to 1 over x squared. Shh. Thank you. Quiet down. What's the difference between a truncus equation and the rectangular hyperbola? What can you see the difference? It's not a square one. One has a squared and the truncus doesn't have a square. Truncus has a square, rectangular hyperbola doesn't. I'll show you later. 1 over x squared is a truncus, 1 over x is a rectangular hyperbola. Okay? Now, same things again, these are the properties. Just like your rectangular hyperbola, you had two asymptotes. You had a vertical asymptote, and you also had a horizontal asymptote, right? Reason why you have these two, because when x is 0, what's the problem? If x is equal to 0, what's the problem? It's undefined. That's why x can't equal to 0. That's why it's an asymptote there. Because if you've got 1 divided by 0, it's undefined. Why do you have an asymptote for y equals 0? What's the reasoning for that? Just like the other one. What's the reasoning?
Undefined.
It's not undefined. It's why is it that y can never equal to 0?
And it wouldn't be a moving, like, it wouldn't be a graph, it would just be...
Not that. If it is moving, why is that, Nikita? Not the y-intercept. Y-intercept is not occurring because x can't equal to 0. But you can't have an x-intercept. Why is that? Why can't you have an x-intercept, Ben? Yep, you can't have a y-intercept in this case because x can't equal to 0. And remember, we're going to find y-intercept, x equals 0. But x can't equal to 0. It's going to be undefined. So you don't have a y-intercept in this case. But why can't you have an x-intercept? So when y equals 0, you're meant to be able to find the x-intercept. Why can't you have it? That's something else. Something we did last session.
No way. No way.
Quiet down. Ben. Thank you. Ben.
If y is 0 times x squared over.
That is definitely one part that if y was equal to 0, if you times both sides by x squared, 1 doesn't equal to 0. Now, not that, but think about rectangular hyperbola. What happens when I put a 2 here? If I have 1 over 2 squared, what does that equal to? Can I please have wheel? 4. So it becomes 1 over 4. If I put in a 3, what does that become? 1 over 9. Sydney, if I put 1 over 100 squared, what does that become? 1 over 10,000. What's the problem? What's happening? A quarter, 1 9, as I increase the numbers 2, 3, 100, what's happening?
It's getting smaller.
It's smaller, but you never get 0. Because you keep getting smaller and smaller and smaller, but never equal to 0. That's why you have an asymptote when y equals 0. Sorry? It's never 0, yeah. Because you can always get it smaller. You can always do 1 divided by the value, and it always gets smaller. Okay? Now, this is what the graph looks like. I want you to copy this down. This is the graph of a truncus function. What I want you to see, as you said, the values are meant to get smaller and smaller and smaller over time. That's why you have an asymptote. It can't get to 0 because you can always make it smaller. So it gets smaller and smaller and smaller. It gets closer to the x-axis, just like your hyperbola function. But what's the difference? Hyperbola has negative values down here. Why don't I have any negative values down here? This goes back to what Lauren said before. Why don't I have like a rectangular hyperbola? Why don't I have that part? No, something else. Why don't I have any negative values down here?
Because if the x was negative, then it was squared.
Perfect. That's what you were saying. So what happens when you square it is it always becomes positive. Doesn't matter if I put a negative there. If I put -1, you square it, it becomes 1/1, which ends up being the same thing. That's why it's symmetrical. If you put a 1 in, it's 1. If you put -1 in, it's still 1. If you put in a 2, it's 1/4. If you put a -2, it's still 1/4. That's why it's symmetrical. That's why it's a truncus, because it looks like a tree trunk. Okay, that's why they call it truncus function. Yeah? Okay, so that's the name. Okay? Tree trunk, truncus function. There you go. Now, this is your 1 on x squared function. I want you to copy down the asymptotes. X is equal to 0. And your horizontal asymptote, y equals 0. Copy that down for me. So this is your basic graph for 1 on x squared. Okay, and it's going to move exactly the same way that you learnt for hyperbola. A rectangular hyperbola, left, right, up, down, is exactly going to be the same way. And you're going to move those asymptotes left, right, up, down. Okay? No, it's just that the graph looks like it is, but it's not. It's getting closer and closer. So that's what an asymptote means. It means it never touches y equals 0. Okay? Sydney? Like this side? Yeah. You squared. When you put a -1 in, squaring it still makes it positive, so that's why it's a positive value rather than a negative value. That's what I'm saying. So down here, that's negative y values, but you can't have a negative y value. No, it's just you can't have a negative, it's always positive. So this is the y values. If I put in a negative number, I still get a positive y value. So what positive y's are up here? This is negative y. Positive y. Oh, it doesn't matter if I put a negative here. If I put a negative in, I still get positive. So the coordinates are always positive. I'll explain it to you later. Yeah, I just want you to copy that one down. Yeah. All right, next one. Now that's exercise 4B. 4C, same things. You only need to know the shape and its properties, then you can start sketching, yeah? So here we go. Square root functions. This is what a square root function looks like. Square root of x. Okay? Square root of x, there's only one property that you need to know. What's the property for a square root function? What can't you do?
Negative.
You can't have this negative values. So the only thing you have to worry about is x values can never be negative. See, unlike this one says x can never be 0, and you can never have a y value of 0. This one says, you can put any number in here, you can square root any number except for negatives. So, when you sketch the graph, you should expect nothing to be on the x-axis that is negative. See, this is all the negative values. You don't expect to have any negatives, because it's only positive values that you can have. So all the positive x has values. You can always square root a number. So this is the shape of a square root function. Okay? That's a shape of a square root function. So copy those two down for me, because I'm going to teach you transformations, how you read left, right, up, down, and you're going to do exactly the same as you did for 4A, your homework sheet, onto these two. Exactly the same way. The way you read it, how to know left, right, how to know up and down, it's exactly the same ways. Okay? So copy those two down, and I'll do two examples.
It doesn't get the y.
No, never. Just keep going up. It keeps going up and getting closer and closer and closer. It gets
Wait, okay. Because I thought it was fine.
Just keep getting closer. Gets closer.
Like the truncus, right? Like, why is it like why?
Because you're squaring it.
Yeah, but the one that like
The other one wasn't squared, that's why.
oh.
Yeah, this one's squared. The other one. Yep. Yep. But for now, I'm just going to teach you how to sketch it. Yeah? All right. Year 11's quiet down. Let's do an example now. Let's read. I want you to copy this down. Right now. I want you to copy exactly the same things that you've been doing. What the A, B, and C does. This is your truncus function. See, the difference is you have a square here now. Over here, I've replaced instead of the x, I've got, sorry, that should be B and C. I'll change this to B. That should be B there. Whoops. Oh, how do I remove that?
Yeah, you did. You went whole pointer. You're like.
Yeah, I did.
So you went all over.
Yes, I did.
Alright.
Wow.
That's meant to be B and that's meant to be C. Okay, just so you keep it consistent.
Let's have a think again. What does the C do to the equation? So this is my truncus. What does the C do again?
Up, down.
Up, down. So if this number is plus, it's up. If it's negative, it's down. What does the X plus B tell me? Can I please have Finn? What's X plus B tell me? Left or right. How do I find out if it moves left or right, Hamish?
By making it equal to 0.
Fantastic. Let it equal to 0. X plus B equal to 0. Solve for X. Now if X is positive, it moves to the right. If X is negative, it moves to the left. Last one. A is always the tricky one. What does A do again? There's two things that it does. What does A do? Number one.
Left, right.
No, left and right is your X plus B. What's A do? Wait. Shh. Akita? Good. It makes it wider or narrower? Wider or narrower. So the larger the number, it makes it wider. I mean narrower. The smaller the number makes it narrower. I mean wider. I gotta keep getting those two mixed. But then there's also one more thing. What's the other thing you have to pay attention to? If it's negative. What happens when it's negative? It flips on the x-axis. Just like your quadratic, you know how you remember positive is smile, negative is frown. Well, in this case here, if you have a negative truncus, it goes both on the bottom. Fantastic. This is a negative. This is a positive. That's what I want you to copy down. Will, I'm talking. Watch this one. 1 over x squared is both of them on the top. If you have a negative a, so if there's a number negative, it will swap them both down. So smiley faces, upside down faces. Yeah? It's exactly the same property as say negative, we'll flip it down. How do we feel? Same description as last time, the only difference now is you've got a square in there. Okay? Okay, exactly the same. So that's your negative, that's your positive. Okay, so that's all the properties you need to know for truncus, and I'm going to show you on GeoGebra what happens when I move left to right. Asymptotes will follow, these two asymptotes will follow, everything will else go the same. Okay, so here we go. Let's look at an example here. I'm going to go to my truncus function. So here we go, this is my truncus. Okay, 1 on x squared. Now, watch what I'm going to do. I'm going to add a +1 on the outside. Remember, if I put a +1 on the outside, what does it do again? Up 1. So remember, if I put a +1 on the outside, it will move up or down. So watch this. I will put a +1. Listening, boys. If I put a +1 here, can you see how it's just shifting up? But what is shifting up? See, what I want you to copy down is when you're drawing it, there's an asymptote. See, originally asymptote was at 0. When you shift the graph up by 1, the asymptote now is at 1. See, when I put a +1, it's at y equals 1. Okay, I want you to keep that in mind. When I put a +1, asymptote, no, I'm just showing you. When I go to +2, asymptote goes up to 2. When I go asymptote 3, it goes up to 3. Yeah? You can see how it just goes up and down. So the only thing that changes is your asymptote. But look at the vertical asymptote. It doesn't change. See, the vertical asymptote doesn't change at all. Now, watch when I change B. So this is B. When I change B, it should move left and right. Now watch this. Wait. Shh. If I change it to 2, can you see how when I change to +2, it goes left by 2, and you got your asymptote. This is what I want you to do when you're sketching. Vertical asymptote, horizontal asymptote. Exactly the same way you did for rectangular hyperbolas. Finn, no phones in my class, I'll let you pick it up. Here we go. You got your horizontal asymptote, vertical asymptote at x equals -2. Easy? Okay, so left, right, up and down. Now let's have a look at what happens with A. Let's look at A. I said it's going to go narrower or wider. Now watch, as I increase the value, see it's getting wider, it's pushed out. Yeah? It's getting larger, it's getting away from the axis. Yeah? Whereas if I decrease it, it gets closer and closer to the asymptotes. Can you see that? Okay, so when I increase the value, it spreads away just like your rectangular hyperbola. So remember last session, when I increase the value, it moves away. Oh, it's not moving away right now.
Are we going to have sax back today?
Yes, we are. But at this point, I'm just teaching this.
Okay.
Thank you. All right. Also, another one thing, remember I said...
What happens if it goes negative?
Yep, that's good. That's what I was going to show. Now, watch year 11s. When I change A to a negative, watch what happens when it's a negative. See, it just goes upside down. Now, if I increase the value, it just spreads out. It spreads away from the asymptotes, yeah. But if I make it a fraction, so if I change it to negative 0.5, it gets closer and closer to the axis, or the asymptotes. Okay, so point 0.2.
Zero or no?
No, because then it won't be a graph. Zero. Yeah. Yeah, so if you just put 0, oh wait. Yeah, it just goes flat. Because 0 divided by anything is just 0. Yeah? All right. So that's what your truncus function is. Now, let's have a look at this example. I want you to read this for me. Let's picture this. So, Trent, while you're speaking, here we go. X minus 2, what do I see here? What does this tell me?
It moves left.
Not left by 2. Right by 2. X minus 2 equal to 0, solve for x. That tells me right by 2 because it's positive. What's the plus 4 tell me again, Simone? Up by 4. When you're sketching this, Finn, stop talking. I'm going to move you to the front. Yeah? Here we go. It's to the right by 2. Right by 2, so I'm drawing the vertical asymptote. Right by 2. X equals 2. Up by 4. So I draw my horizontal asymptote. Y equals 4. Now what kind of graph do I have? What kind of shape is this? Is this a truncus, hyperbola, or square root? Truncus. So if I were to sketch it, this is what you're going to do. Draw the truncus. If I draw the truncus, this is what it looks like. I'm going to do it in red. Here we go. We're going to draw a truncus function. There we go. That's your truncus. We've got 1 over something squared is a truncus. You told me it's down up by 4 to the right by 2. So that's what I did. Right by 2, up by 4, truncus shape. What am I missing? From your homework sheet, what do I need to add on? I got the asymptotes there. They're given. Intercepts. Now, how do you find intercepts? Let x equal to 0, let y equal to 0. Exactly the same way as your homework. So let's do this now. How do you find the y-intercept? Ryan, how do you find the y-intercept? What do you do? Yeah, you got to make something equal to 0. Let x equal to 0. So in this case here, y is equal to... Yeah, but that's for the asymptote. Now we're trying to find y-intercept because we moved it away. So that's why you can have a y-axis intercept. Yeah? So when you have x equals 0, 0 minus 2 squared plus 4. What does this become? What do I have here? I've got 1 over what? Ben. I'm trying to solve this fraction. 1 over what? Minus 2 squared, which is 4. 1 over 4 plus 4, that's 4 1/4. Yeah, so you got 4 1/4. That just tells me this is your y-intercept. 0, 4 1/4. Now looking at that graph, are there any x-intercepts? Does this graph touch the x-axis?
Yes.
No.
Oh no.
It's gone up. Doesn't touch the x-axis, it's right down here. So it doesn't touch it. These are my asymptotes. There's no point solving for them, would it? It just keeps going closer and closer to y equals 4. That's what an asymptote means.
What, eventually it would hit it, yeah?
No.
What do you mean?
Because it just keeps going to the asymptote. That's what I was saying. Asymptote means you're approaching that value. You're approaching 4.
What happens when it hits it?
It doesn't hit it. That's why it's called an asymptote.
It gets to as close as it can, and then what?
It just keeps getting smaller and smaller.
No,
It won't. It's like saying this, Ryan. If I half 4, what's half of 4?
2.
What's half of 2?
1.
What's half of 1?
0.5.
Half of 0.5. Can you ever get to 0?
What are you saying? But like,
No, I'm just asking. Can you ever get to 0?
probably.
So what number would that be? How many times would you do it?
Yeah, you're right. But like, we don't have a measurement for like that small units.
We don't have a measurement, but mathematically we do. Okay, so that's why on a number basis, it will keep getting smaller, but it never equals to 0. So it's the same thing. Okay? No, I'm doing another one. All right, here we go. Next one. Ryan, don't speak while I'm speaking. Here we go. Exercise 4B. You'll be sketching these graphs exactly the same ways, but I want you to read what you see here. So let's do the first one. Good. Negative 3 asymptote means to the left by 3. So this is left 3. Next one, C. Will. What do you see in this one? Doesn't what? C.
Oh, it's C, sorry. It goes right by 2.
Good. Right by 2. And then you got this negative. What does that negative do? Good. Fantastic. There you go. Okay. Now, let's go to a square root example. Same thing. I want you to read left, right, up, and down for square roots. Okay. Now, same thing again. You got a plus 3 on the outside. What does that tell me, Hamish? Up by 3. Up by 3. What's the x minus 1? Oscar. What's the x minus 1 tell me? 1 to the right. Okay, and now if you had to sketch this graph, you literally follow the transformation. Now I told you to sketch the graph of root of x. This is what root of x looks like. So if you were to sketch up by 3 to the right by 1, it's pretty easy. Move this up by 3 to the right by 1. So this is what it looks like. Up by 3 to the right by 1. This is where the starting point is. There you go. Done. You can't show that, that's why. So that's why it's okay enough just to draw your graph like that. Okay, good. Good point. There is no other side because remember you can't square a negative number. So you got that side. Now I'll show you. What I want you to see is, watch me change to a square root function. That's a square root, yeah? Watch what happens when I change b. Quiet down.
What's B?
This is b. Can you see how I change from plus 1 moves to the left 1? If I go to plus 3, it moves to the right by 3. See that point? It just shifts this graph, but you just give a square root function.
Try and draw all the way.
All the way. All the way. Now watch, if I put a plus c, put a 1, put a 2, it just moves up. Minus, goes down. Now here's a tricky question. What happens when A is negative? So A is the number that's outside if you have that as negative. What happens then? It flips upside down. Fantastic. And this is what it looks like. So if I change A to negative, it goes upside down. Now the cool thing about square root functions, not only can you flip it upside down, you can also flip it on the side as well. So how do you do that? And that's only special for exercise 4C. I'll show you how it's done. Negative on the outside will make it upside down. How do you make a negative so that it goes the other direction? Negative on the x. So watch. I'm going to change the equation and I'm going to put a new letter in here. So d times x. And you watch. I'm going to change d to a negative number now. Watch when I change it to a negative 1. Now, this is where it gets interesting. I have now, starting at 3y, let this equal to 0. If you solve for x, what does that become? Not negative 3?
0.
No. Here we go. If I solve for x, remember this same thing. Negative x plus 3. Plus 3 equals 0. Plus 3, because it's negative x equals to negative 3. 2 negatives become... That's what I taught you. I said if it's positive, it moves to the right by 3. So to the right by 3, but you see that negative in front of the x makes it go this way. Okay, so it's negative on the y-axis. If Felix, thank you. Negative on the x will make it flip horizontally. Negative on the function, just the square root outside, will flip it on the x-axis. Okay, that's the only special thing. That happens with all graphs. It's just that the graphs that you've been seeing is squaring itself or it's symmetrical. That's why you don't see it happening. But square roots are nice for you to see it. So this is the first introduction with the negative on the x. Okay, the negative on the x will move it this way. Okay, so let's do an example now. I want you to read them. Here we go. This is what I want you to see. And I want you to copy this down. Square root, negative on the outside, what does that do again? It flips on upside down. So this is what it looks like. It goes down. What happens when I have a negative on the x? Opposite. Fantastic. So it looks like this. Now, what if I wanted to flip here? Fantastic, Hamish. Two negatives. Two negatives. If you wanted to go down like this, it's negative of negative x.
Wait, it is parametric.
There you go.
So it is
Okay?
parametric.
Copy that down for me.
It is parametric.
Sorry?
Parametric.
No, it's not parametric at all. Just a square root function. Okay? That's what I want you to copy down. So square root x is the blue graph here. Negative of it becomes the red graph on the outside. Inside it, we'll make it horizontally. And if you have both negatives on each one, it'll go down. Okay, so that's what I want to write down. Positive, negative on the outside, negative on the inside, negative on inside and outside. Oh my God. Okay. And you can move it left, right, up, and down just the same way as I taught you how to read it. Okay, so numbers on the outside will move up, down, numbers on the inside will move left, right. And that's what I want you to do. It's not hard. It's the same things. Okay? For each one, I want you to find the x-intercept, y-intercepts as well. Okay? Let x equal 0, let y equal 0. It's the same drill, but that's reading the graph. Okay, I want you to start on exercise 4B, truncus. Get the asymptotes, find the x and y intercepts. Same way as the hyperbola. And I want those homework sheets as well. I'll tick off your name before you go, just so I know who hasn't had your man. Okay? All right, fantastic. Thank you.
Do they touch the origin?
Yep, they all touch the origin. Yeah.
If you had to label the steps and have like same.
It'll be 0, 0. Fantastic. Yeah. Because when x equals 0, square root of 0 is 0 as well. All right, here we go.